Paul Callaghan is the founder and director of OLEOLOGY. He has been involved in the oil and gas industry for over 33 years. So please welcome Paul Callaghan.
So OLEOLOGY operates out of Cardinia, so we're a locally based company just slightly inside the radius down to Henderson from here. We work with a company out of the US called MySelects, and it's a very innovative product in the development of water treatment in the oil and gas field. So currently we're working within an environment which has oil and water discharge limits which are reducing. The cut of water in the offshore applications is increasing the load on the water treatment systems. There's, for those onshore operations in washing of drill rod wells, there's also the opportunity for discharge or recycle of water treatment. And into that then comes the consideration of wastes. Wastes in all aspects of whether you're onshore or offshore become a considerable consideration in the total cost of operation. Into that, when you then look at the cost of water treatment, whether water supply is bountiful or whether it's somewhat limited, you then consider, having treated the water to discharge quality, what the additional parameters would be if you were to recycle that water. All of those factors come into consideration, and particularly as the life of the operation extends, become even more considered. Additional to that are some other new and emerging contaminants that need to be considered, and we'll talk a little bit about those at the end, namely mercury and PFAS. So just quickly, the MySelects technology, which was developed about 25 years ago in the US, is a non-toxic, non-leaching, it's a permanent infusion, so it becomes an adsorbent into various filtering type media. Within that media, we then have the opportunity of either filtering per se or coalescing and capturing oil, or that further step of enhanced oil recovery, which is where it's finding a lot of traction around the world at the present stage. It's a permanent infusion, so whatever we put into the water stream for the removal of the contaminant we're targeting to take out, we also take out any chemistry because it's a fixed chemistry. So there's no future liability associated with the process. One of the problems that we've been becoming more aware of with time, and we had a senior lady from the US EPA address a conference in Melbourne back in 2012, where they discussed the ongoing contaminant issue, in that contaminants that were targeted for removal were found to be altered in state in some processes, such that when the after treatment assessment was done, those particular contaminants weren't found in presence any longer. What was found later on was derivatives of those contaminants in shorter chains. Thereby a lingering problem exists, and further cleanup was required. And when we get to talking about PFAS a little bit later, that is one of the large issues that emanates from that particular pernicious contaminant. So MySelects is an oil absorbent and it's hydrophobic, which means in terms of waste, it's very light when you remove a saturated cartridge. So it's used to capture and separate oil in a stage. It's also used in enhanced oil recovery, which is particularly valuable in emulsified oil stages. Very difficult for removal in most other processes. And then in the final stage, the third stage, it's used for its polishing, achieving low levels of discharge, or in those cases where you have emulsified or semi-volatiles that are unable to be removed by other processes. These can be captured for safe discharge or also for recycling of water. This chart is the one that makes the most amount of difference, because if you understand this chart and the simple science that's associated with water treatment, it all flows from here. So moving from right to left, that is left to right I should say, different types of well-recognised water treatment and oil separation systems are listed there. The limitation for any particular type of oil water separation system amounts to how easily the water droplet and the oil droplet are separated. Oil droplet, being a lighter specific gravity, rises to the surface. And that's akin to any floating device. The larger the mass of specific gravity of difference, the quicker it will rise to the surface. So as the oil droplet size decreases as you move from the left to the right, so the level of challenge increases to get the water and oil to separate, ultimately ending up with no separation at all because you have a homogeneous mix essentially. So to put that in perspective, we've tried to put a few sizes together to give you an idea of what we're talking about. So 50 microns, which is at about this size here, traditional plate separation type systems, everybody would be fairly familiar with the coalescing effect that they have. That will get you free oil removal, which is really akin to what most industry has. Cyclones will remove dispersed oil, so we're beginning to move down to 25 microns. 50 microns is about the diameter of a human hair. And for those of us with plenty to share, you've got an abundance of 50 microns rooted in the top of your head. A human blood cell is about 5 microns, about 1/10 of the diameter of a human hair. So you're getting down to something fairly small. So elements of oil dispersed through a water body at 5 micron, which is over about here in the chart, they will take, if just left standing, will take about 330 hours to rise 30 centimetres. Now, you enhance that by enhancing gravity, and centrifuges or hydrocyclones enhance that gravity separation and accelerate that rate. But you're still talking about significant time, and the time of throughput, and particularly in turndowns, you suffer significantly in terms of improved or discharge not reaching the targeted levels. That equates to about 2 weeks if you were to leave oil and water to stand and separate. So all of that is further compounded by the addition of these elements: monoethylene glycol or glycols, surfactants, polymers, and on the very end there I've included the ubiquitous PFAS and what it does. All of those tend to move oil droplets from reacting like a free or dispersed oil further over to the right hand side to act more as a dispersed emulsified to soluble, semi-soluble oil, making it more difficult. MySelects technology in its simplest form is a filter. On the left hand side, the brightly coloured filter is a clean filter. On the right hand side, 4 filters sitting adjacent to it are in fact saturated filters. MySelects filters, if compared to, say, a granular activated carbon, which will hold somewhere between 10 and 20% of its weight, that's carbon, MySelects will hold about 200% of its weight in captured oil contaminants. Highly efficient, hydrophobic. It becomes a dry cartridge when removed from the vessel. The picture to the left-hand side shows some operators changing out those cartridges. No special tools required, very simple operation, low risk, high efficacy of removal, low capital cost. It's a very small set of filters and filter vessels. Ecologically friendly, these are able to be incinerated, low cost of transport and storage. They're deployed in many places throughout Australia right at the present stage, principally in the oil and gas industry, which is where MySelects have focused all their attention through the Middle East, through the oil sands area, and also in the Gulf of Mexico. Through Australia, we've done a lot of work with a variety of people and also in a variety of industries, including the mining industry, which interestingly has similar problems as what the oil industry does. Low levels of discharge requirement, high solids, fluctuating inlet streams of both solids and oil and very fine particles. Some installations in the Gulf of Mexico, which are principally MySelects installations. The main item I wanted to draw your attention to here is the types of volumes of throughput in the second column from the right-hand side. Discharge levels that are continuously applied and maintained, principally the levels of discharge that are achieved by MySelects as a polishing element are less than 3 parts per million. They can be used in full flow or in a duty and standby system, or simply as a mechanism of backup in the event of an outage in the upstream processes. To give an idea of the efficacy of MySelects compared to a standard system, or a traditional system we should call it, the right hand, or the red square rectangle sits on that the outline of the base of the previously installed activated carbon system, which was used as a polisher on an offshore oil rig. The yellow highlighted box on the inside is the same volume of treatment through the MySelects system. Very compact, small footprint, but you've also got to remember there's a very small amount of waste associated with something of that size which treats the same volume. MySelects coalesces as well as captures, which becomes important in understanding how in a series of polishing cartridge elements, as we have up here, inlet, first stage, second and third stage in a polisher, we're able to remove more hydrocarbon on the way through. MySelects also removes organometals as well. So in association with hydrocarbon removal, it will remove organometals and will remove mercury in its various forms. But a little bit about that later. So not much use having a great system if you can't actually get it onto a platform which has got a problem. So the beautiful thing about MySelects is it's able to be deployed as a retrofit to existing systems and existing operating platforms in various stages or in various forms. So they're able to be fitted on to existing water treatment plants as a retrofit and final stage polisher, and in fact can be used in certain circumstances where monitoring systems are put in place upstream of the MySelects or downstream of the traditional and original system of water treatment. MySelects can be bypassed in normal operation when system is running at full flow in peak condition, and then only diverted through in the sense of upset that may occur or outage, such that it's able to be put through the MySelects to maintain operational systems. Some of the things that we've done locally, just to highlight our ability to manufacture here in Australia. It still does exist, and it's great to hear Matrix is in full flow, because I love the idea of building things in Australia and marketing them. Manufactured in Welshpool for us by a local company, Basong Engineering. A hire skid like this that we've developed for use was deployed on a northwest shelf platform just recently, and is currently now being deployed over in the Philippines for Shell. It can operate at 80 cubes per hour in duty and standby mode, or that's at 100%, so 50% flow would be 40 cubes an hour, can peak at 100 cubes an hour in a footprint that's 3 metres by 2 metres. Another one that we're doing right at the present stage, and working with Chevron to deliver for them for the CO2 re-injection program. Skid-based system, fully fabricated again in Welshpool. This actually has 2 of the other 3 stages that we talked about at the initial part of the presentation. Just hiding slightly out of screen, this particular vessel here is the primary stage oil recovery system. that can recover oil down to 5 microns in droplet size, and about 95% oil only in the discharge or recovery phase. So if you're seeking to work in a plant which is treating water and you've only got a small amount of oil, ideal, because the waste level is very small. You don't have a large volume of oily water to remove as a waste product. This only removes pure oil essentially, which limits the cost of waste removal from site. Flowing from that then into what would be the third stage of a normal system. The second stage on this particular plant, which is the MySelects polishing filters. Now this particular system is designed about removing the more difficult to remove BTEX components, and principally benzene as a targeted component of removal. As you would know, highly soluble and difficult to separate from water in its natural state. This system is a lower flow, particularly designed around less than 10 cubic metres per hour, but we're seeking contact time and removal for benzene down to less than 50 parts per million benzene in free state. Just to give you a little 3D perspective on what this actually looks like, which might be a little bit clearer than what we showed before. So just on 8 metres by 2.5 metres in size, able to be removed from the workshop as a complete unit and taken to site, which is not dissimilar to what we do with other pieces of plant in water treatment. So either on a skid or containerised. The system is automated with PCS output to the main plant. Operator intervention is minimal, with the exception of moving from the duty train to the standby train. Oil content is monitored by spectrography or microspectrography, which enables the discerning between water, oil in water, oil or air bubbles from oil in water, and also particles from oil in water. Very clever piece of kit. So if we're manufacturing, as I said, alternately a wastewater treatment plant, which is a type of thing that we've deployed for some of the shore-based facilities around supply bases, drill rod cleaning and the like. The system would have something similar to this, all based in a 20-foot container, able to be remotely monitored and operated, so very little operator intervention required. The whole system can be automatically backwashed, and I'll just quickly talk you through it. Principal oil water separation, again with very low levels of waste for oil removal. Backwashable media, which is a MySelects product that was developed. So by the time we get through the primary stage, the 2 secondary stages, each stage in the secondary stage is the 95% removal down to about 2 microns of oil droplet size or oily solid. We also remove in here oily solids, being emulsified oil or oily solid down to 2 microns in size, and then polish from there onwards through the MySelects cartridge filtering media. And the final stage, we use advanced oxidation processes to make the water suitable for reuse. So these principally have been deployed down in Henderson and up at Karratha, Dampier supply base, for washing of equipment going on to Barrow Island. I think a little bit more interesting and a little bit closer to home, some of the challenges that exist at the present stage that we are commonly talking about. Not many people seem to have a problem, but we certainly get some interest and discussion about mercury removal from gas condensate and from water phases. MySelects have a proprietary development which is akin to some of their primary oil filtration media. So it has dual purpose. in that you can also filter oil and also take mercury out in the water phase in its ionic form. But in its gaseous form, MySelects is also well advanced in the studies of what they've done over the last 6-7 years in development of coalescing mercury from the gas phase. Well and truly advanced in their understanding and well and truly advanced in the application of the removal of mercury from gas. And the closer to the wellhead that we're able to do it, the better for the integrity of plant. PFAS. PFAS, I don't know how many people in the audience would be much aware of PFAS. We've got one of the Australian experts sitting in the audience at the moment, Dr. Jimmy Xiao, who we're lucky enough to have in Perth, and we've taken advantage of Jimmy's locality and his expertise to assist us in development of PFAS. We've been working in the PFAS space and started working with some work that was done at the Perth airport about 8 years ago, the removal of PFAS. So PFAS is primarily one product that you may have heard about because the RAAF are in significant trouble over in Williamstown with groundwater contamination. PFAS is a pervasive product that is a combination of 4,700 different compounds that make up PFAS. Teflon is a commonly known product that you would all be familiar with in use because it lines most of the pans that would be sitting in your kitchen. It's also Teflon tape, which we use a lot in sealing of pipes in many applications. Interestingly enough, as we've gone down the process of developing our plants for removal of PFAS from water, we had significant trouble in finding sealants that don't contain PFAS compounds. It is pervasive. As we sit here in the audience at the moment, the carpets, the clothes we wear, the lanyards, just about everything we touch will have a compound that has got a fluorotolymer of some sort in it. It gets into the groundwater. It's got a half-life of 43 years. It's highly stable. Double fluorine bonds are probably one of the most stable bonds and strongest bonds known to science. They're stable and can't be thermally oxidized until you reach about 1200 degrees Celsius. We are assisting a number of companies at the moment in the removal of contaminated water. It's something that we need to be aware of in the oil industry because it will become part of that which we're assessed in terms of water discharge at the present stage, and I can highlight that by talking about some fuel terminals over on the east coast of Australia. We're engaged in providing them water treatment for hydrocarbon removal from areas where they had leachate groundwater which had hydrocarbon in it. At the very last minute, during our process of assessment of what would be required, they asked, could we remove PFAS from the groundwater because it also seemed like they might have some there. They had been requested by the relevant EPA and the state to assess the groundwater for PFAS, principally because they had done firefighting there. So anywhere where firefighting has occurred or firefighting training and foam has occurred in the last 30 years, there will be PFAS in the concrete, in the ground, in the soil that will leach into the groundwater and will be causing issues in an ongoing sense. Unlike hydrocarbons, which also get into the ground and groundwater, they will gradually break up. So management by natural attenuation is often the answer to the problem and the question that's posed, how will this go away? PFAS won't. PFAS is assessed, unlike oil in water at parts per million or benzene at parts per billion, PFAS is assessed in parts per trillion. It is extremely low levels that we will be charged with in understanding and managing to achieve. That's it. That is all I have to say. Thank you.